Next talk is from Joe Johnson, who actually gave a talk last SuriCon as well. Very interesting. Looking forward to all sorts of ways to simplify Suricata performance testing. His talk last year was very actually valuable to me and to the community as well. Looking forward to more of it.
Hi, so I'm Joe Johnson from Kikamon, and I'm going to kind of talk about some ways to kind of simplify performance testing of Suricata and some tips and tricks and kind of some of the other stuff I've been playing with related to performance. So my day job, I'm mostly a software engineer. Once in a while I dabble in security research. I've been working on network security for almost 4 years now, mostly with Suricata and Zeek. And before that, I worked on antivirus at Microsoft. So kind of some of the stuff I want to cover today is just using TRex more effectively. Off the shelf, it's kind of clunky, it's a bit hard to use, so go through some of the techniques we've been using to make our lives easier and make us more productive with it. Talk about some of the traffic profiles we like to test with. And then talk about actually trying to set up like a proper 40 gig test harness, not with live traffic, but with actually reproducible traffic that you can run again and get the same results. And finally, I'm going to talk a bit about starting to use profile-guided optimization on Suricata and seeing what performance improvements we can get once we kind of know what traffic profile we're going to be running against. So for those who aren't familiar, TRex is a free open source traffic generator from Cisco. It's probably the only free thing from Cisco. It's, as Tobias mentioned, it can easily go up to 100 gigs plus on a relatively low-end machine as long as it's got the right network card. It's great for taking kind of a relatively small PCAP and making it look like a ton of different clients and servers are talking to each other. And it also has capabilities for tracking latency and jitter for running in IPS mode. So if you're actually trying to validate IPS features of Suricata, it'll tell you how much you're messing up the traffic. So kind of the first technique we've started using is we wrote some tools to take PCAPs in and spit out TRex configurations based on them. So this makes our life a lot easier in terms of not having to go manually tear apart a PCAP and then build up the config file. We started using this partly to chase down some memory issues in Zeek. So we were trying to run SMB torture through it as aggressively as we could, and it has several hundred flows in it. So taking that PCAP apart by hand was not going to work. So kind of the reasons you'd end up like, instead of just handwriting a configuration for TRex, you'd want to use it is, as I mentioned, like testing something that has a lot of impact from the number of flows like SMB, you want to be able to kind of amplify the number of flows. Another thing you can do, like as Tobias was mentioning, his network has a lot of weird traffic on it. So going and individually getting PCAPs of each weird thing on your network and building that would be hard. It would be a lot easier to just take 20 minutes of PCAP, feed it into this tool, and then tell TRex to just make it look like it was 2,000 different clients instead of just one for each of the weird flows you were seeing. So you could actually generate, going forward, similar amounts of traffic without having to rely on live traffic the whole time. And then kind of finally, the other one is if you're testing rule performance, some rules have thresholds where they'll stop firing after a certain number of detections. And sometimes you want to make sure you're actually still seeing its effect across a wider environment. So if you're just replaying a single PCAP, you're going to hit that threshold quickly, whereas if you're randomizing the source and destination address, you'll actually avoid that threshold and keep hitting the rule and see what the actual performance impact will be in production. That said, once you have a TRex configuration, sometimes it actually makes sense to go back and turn that back into a PCAP, now with the amplification of all the flows from the original PCAP. So you can do that pretty easily by just running TCP dump on whatever sensor you actually have TRex pointed at. And what this will let you do is it gives you something now that's highly reproducible. So TRex, you're pretty reproducible, but it's still randomizing the flows, so it's going to hit the load balancer randomly. So this means it'll be the exact same way every time. The other thing it'll do is it guarantees that you can go attach a debugger, so you don't have to try and run against Suricata Live with 20 threads flying around. You can actually go run just against the PCAP and try and debug issues that you were finding under load. So, and one example of how we use this, my colleague Jason, who actually wrote a good bit of this tooling, was trying to chase down some memory issues with SMB in Zeek. So what we needed to do is we needed 10,000, 100,000 flows to really replicate kind of where the memory leak was happening quickly rather than having to wait a couple hours. So he essentially used TRex, split out the PCAP, got a whole bunch of flows, put that back into individual PCAPs, and then fed them in individually, and he could see right away where the issues were popping up. So I just talked about kind of automating TRex, but sometimes we actually do want to go hand-build traffic profiles. There's a couple reasons why. Sometimes there's just not a PCAP that corresponds to what you want to test for. Other things that can happen is you want to actually change the relative proportions of the traffic. So one problem we have is we have customers, we can't just go get PCAP off their environment. So if we want a different amount of DNS and HTTP to replicate a certain customer's environment, we have to go in and use kind of benign, not from the customer's environment, HTTP and DNS lookups, and then tune them so they match kind of the traffic patterns from that environment. And then finally, sometimes you want to create profiles that will exercise very specific code paths. So as I mentioned, just targeting SMB. So this is one of the profiles we use a lot. The only thing missing in it really is SMB. We found it kind of maps really well to a couple of our largest customers. It pretty much is, at least for Zeek, it's almost identical between essentially what we see in the field from our sensors and what we see internally for performance testing. And it's just a mix with a lot of DNS, balance of HTTP and SSL, and a little bit of SSH and RDP. The problem is it's not as good for testing Suricata because the HTTP information is very repetitive and it doesn't hit that many rules. So for that, we have this profile, which is a bunch of PCAPs from malware traffic analysis, and we stack them into one profile and then repeat them as if they're coming from a bunch of different clients and servers. So this lights up Suricata kind of like a Christmas tree in terms of hitting all of the different exploit signatures in ET. Now this is really good for testing Suricata under a high load of a lot of detections, but hopefully this is not a profile that matches your network. So, as Peter mentioned, last year I was here talking about TRex and trying to get up to 40 gig reproducible testing. I didn't quite get it working in time last year. I do have it working this year. So let me run through kind of the setup for that. So right now I've actually got, instead of one box, I've got two boxes, each generating 20 gigs of traffic. So each one of them's got 4 Intel 10 gig NICs built in. Since TRex, you essentially need a out and back for each amount of throughput, so you need 4 NICs for every 20 gigs. I'm using an Arista switch, again, for actually doing kind of the tapping and the port mirroring. And then the actual sensor under test is dual Xeon with 18 cores and 36 threads with, again, 4 NICs to handle the 40 gigs traffic coming in. And then what I'm testing is I'm running Suricata 5 with Hyperscan 5, with ET OpenSigs on PF Ring still, and then with profile guide optimization, which I'll get to in a little bit. So kind of, if you're familiar with TRex, this will look familiar, but essentially the hardware layout is the traffic generators need to basically talk back to themselves by way of a switch, and So there's cables out and back for each one, and then you mirror those ports over to the sensor. Typically, I just use an RX-only mirror, so I'm not getting duplicate traffic, so I'm only ever seeing the packets as they're entering the switch across all of the interfaces going in. For the sensor itself, the NIC offloading is kind of important once you start getting up in the 20 to 40 gig range. So I've got each card has its interfaces bonded together so that we're not getting out-of-order packets from the traffic generators. And then each one has each of its receive queues pinned to a separate physical core. Right now, because I plugged the cards in wrong, both cards are on the same NUMA node, which is detrimental. And then the other thing I did is I actually, because I have 18 cores, I made sure I didn't use core 0, since other things tend to have their IRQ bind to that, and I didn't want to have any interference with the network offloading. So this is kind of what the packet loss looks like at 38.5 gigabytes. So it's doing about almost 6 million packets per second. It's dropping in the ballpark of 15 to 20% of them, which is not bad considering it's a completely naive SuriCata implementation. There's no core pinning beyond the initial pinning of the network offloading. So there's lots of room for tuning and improvement, but it's already pretty close. And this is just kind of the bandwidth. You can see there's a little bit of jitter, but it's bouncing between 38.45 and 38.55 gig. So it's pretty much right around 38.5 on average. And here's kind of the CPU of the sensor under test. And you can see a couple things. You can see the NUMA node without any network cards on it is the lower one, and it's kind of bored. It's not doing quite that much. Whereas the other core with all of the networks on it is very heavily saturated, and each one of those red lines is corresponding to the amount of kernel work being done just offloading the packets. So as you can see, for every one of the physical cores, it's spending about a little more than half of its time just getting the packets from the NIC to SuriCata. Kind of, as I said, the results are not too bad of a drop rate considering the implementation's still naive. And considering that the NUMA nodes aren't balanced right now, I think if I go back, plug the NIC into the right thing, and pin that NIC to it, and then basically pin SuriCata workers for each of those interfaces to the appropriate core, it'll be pretty close to working without drops, although, as mentioned, there may still be some other missed detections that'll happen kind of internally. So that brings me kind of to the last thing that I started playing with while I was working with all of this stuff to kind of build these different traffic profiles and test with them was I saw a talk about how Zeek was starting to look into using profile guided optimization. And if you've got a decent idea of what kind of traffic you're going to be seeing, you can actually go measure how SuriCata is acting under that load and go back and feed that back into the compiler with the profiling data, and the compiler will start making optimizations. It'll decide what loops to unroll, it will do branch prediction, and it'll take a bunch of hints from how SuriCata was actually running instead of what compilers normally do, which is guess. So because I was trying to do this with all the latest optimizations, I started with GCC 9 instead of the default on the machine. And so kind of the first thing you have to do is you've got to build SuriCata to generate this profiling information. So you've got to specify C flags to generate it, and then you also need to specify LD flags for the coverage libraries or it won't run. And then you can play it back with a couple different kinds of traffic. You can use the live traffic from your environment. You can just feed it a PCAP, or you could take a PCAP, amplify it with TRex so you get a lot more load and a lot more activity in the flow manager, and use that. All of them will work reasonably well. The one thing with live traffic is this is about a 20 to 25% performance overhead once you turn this on. So if you want to run it on a production system, don't do it unless you've got a good bit of headroom on that system. Now, once you've got kind of the profile, which you can get within a few minutes of running typically, you can go back and build the optimized binary. So you take the outputted profiling files, you feed them back in. You also have to turn on profile correction. This is because Suricata is highly multi-threaded, and the profile collection code is not. It is not thread safe at all. So frequently things are overwriting each other, and it's actually not getting that clean of profiling data. So this tells the compiler to go back and guess and do its best effort of taking that profiling data and assuming it's not all going to be 100% accurate, but do the best with what it finds. And then finally, you need to go turn off coverage mismatch errors, because part of Suricata's build process, with configure, it tries to build a bunch of different things just to validate what the compiler can and can't do. And unfortunately, most of those ephemeral builds get thrown away as part of the build process, so there's no profile information for them, and you'll error out if you don't tell it to start ignoring those errors. But you need to be careful, because if you use bad profile data, it'll ignore those errors when it goes to actually build Suricata as well. So you need to actually keep an eye out. You only want that off kind of in the config step. There's no good way to split that right now. So here's kind of some of the packet loss stats I was seeing broken into 3 parts. So the first one, I actually started with profile guided optimization on GCC9, and it was not great. And then I went back to get my baseline without profile guide optimization, but I messed up. Forgot to reset the compiler to GCC9, so I actually just compiled with 5 and got a surprising result. Just compiling it straight with GCC5 with default options is actually significantly more performant than anything built with GCC9. And what I'm pretty sure is happening is I think GCC9's default optimizations are less aggressive than they were in 5. So essentially there's things that are turned off when you go to 9 that need to be turned back on. But as you can see, when you get over kind of to where I actually did run with GCC9 again, that the profile guided optimization actually did have a decent improvement over the existing one. And then, as I said, the traffic I showed you before of my initial 40 gig testing was I went back and built profile guide optimization on 5, and got probably the best results I was going to see. So kind of the big surprise is, as I said, GCC9 actually regressed, so I need to go figure out what's going on there. And it's still doesn't give you quite enough to handle 40 gigs on its own, but other tuning, you can probably handle 40 gigs on this box pretty easily. So some of my next steps are I want to publish more traffic profiles. I only went through a couple right now. We've got more in-house. I just have to go clean them up and make sure there's no proprietary PCAPs in them. I want to research the profile guide optimization a bit more and hopefully get that available as part of building Suricata and make it easier to do instead of just doing C flags and hoping for the best. And I kind of want to keep improving some of that tooling to make TRex easier to use. So right now we've got some stuff to make it easy to kick off, but I want to kind of improve that for managing TRex, especially like across couple machines generating the traffic. And here's some links to kind of like some of the source that Jason and I are sharing of the tools we have been building and some of our traffic profiles, and kind of expect to see these keep improving. Victor?
Thank you. Great work. So my initial thought on the GCC9 thing is that maybe they are trying to protect us from the recent CPU bugs, and
that is another possibility.
we see that. I think all this hardware performance progress from the last 10 years is kind of going away due to these mitigations. So there was not really a question in there, sorry.
So what was the reason that you still stick with PF-ring? Have you looked into AF-Packet, like the current version as well?
So the question is, why are we still on PF-ring? The answer is we only recently updated to a kernel where AF-Packet was comparable. So we're a little behind on the kernel we're running. And essentially, the plan is once we do the next kernel revision, we'll look at cutting over as well.
And the following follow-up question: what with the setup you had, you had like any issues with like generating traffic that generated too big flows for some cores, or was it quite even distribution? So you didn't run into the issue that you had like one flow going into one CPU core and hitting like the 100%?
Did not have too much of that. TRex is not great for kind of hitting that load balancer, like where you essentially saturate one core. So you're not really going to see elephant flows when you're using TRex. You'd need to, unless you explicitly had like one really large flow as part of your test profile that only ran periodically so that it would be locked onto one kind of a 5-tuple. So the 5 tuples are so well randomized, unless you have something really large in your test set, you're never really going to see it saturate any one core.
Thank you very much. That was a great talk. I was wondering whether you envision a future where you would profile your Suricata compile for every run you do, so that you perhaps supply a PCAP and that compiles the most optimal version of Suricata for your environment.
So the question was, do I envision a future where essentially you build Suricata kind of per location it's deployed with profiling for that location? I've thought about it. There would be some tooling involved to kind of be able to kind of spin it up, run for a little bit, decide what the profile information was, and then rebuild locally on each sensor. But it's certainly possible.
Quick question. How relevant do you find the TRex traffic profiling when you generate so much of it in comparison to doing QA for performance testing itself to the production environment? So you generate a lot of traffic up to 40 gig. You tune, optimize the system. How relevant is that to the actual production setup? When you plug it in production, do you have the same kind of expectation of performance?
Okay. So the question was, how relevant is some of this testing to what our actual production workloads? So the one I shared that's kind of like our standard enterprise one has proven surprisingly similar in terms of how our sensors perform on that versus how they perform at least on our largest, most loaded sensors. But that may be specific to just the customers who happen to have sensors with that much throughput, just happen to have that load. Other places we've definitely seen where it doesn't map quite as closely. And as Andreas asked, sometimes we will see in customer environments where kind of the load balancer will end up pinning one core where you'll just have like half of your traffic will be 1 or 2 5-tuples. So we run into that, which you'll never see with TRex.
Quick question. As more and more of Suricata is written in Rust, have you figured out how to figure out how much time is spent in Rust versus C? And is there a profile-guided optimization approach for Rust?
So the question is, now that there's more Rust in Suricata, is there profile guide optimization for Rust as well? And the answer is yes. I did not play with that yet, but Rust does support profile guided optimization as well.
So compared production with your test environment where you generate traffic with your TRex, how's the profile for alerts generated?
So the question is, compared to production, how do we generate a profile for alerts? And right now, as I said, we've got one that we know will generate lots of alerts, but we don't really have a great TRex profile that generates alerts about on par with our production environments. So that's one kind of gap in the testing that could be filled in, is coming up with a profile that generates a normal amount of alerts instead of a very large amount of alerts. And then the other thing to do with that would be writing some automation to be able to go back and look at the alerts that were received and make sure you're receiving approximately the number of alerts you expect to be receiving, since that's kind of something that's hard to detect just from the Suricata stats log.
Any more questions?
Victor had one. He asked if we tried CLang, and not yet.
Thank you for your talk. Have you tried link type optimization effects to see if it changes the speed of parsing and so on?
The question is, have I tried any linker time optimizations? And not yet.
I believe you may be interested in the work of Mozilla because it has done some work to do cross-language LTO, which according to them gave pretty good results. The size of the binary increased a lot, but the speed also.
Mm-hmm. Thanks, everyone.